work with the Kenya Ports Authority as a senior electrical engineer in charge of workshops, air conditioning and generators. I also double up as the energy manager in the Port Electrical Department. The relationship between Kenya Ports Authority and MTCC Africa is that Kenya Ports Authority is one of the consortium members of MTCC Africa. The other members include JKUAT and Kenya Maritime Authority. The role of KPA as a consortium member is that it has been supporting all the operations of MTCC Africa, including the pilot projects that MTCC Africa was undertaking. And it has been in the forefront as one of the consortium members in ensuring that the project runs to its completion. My role in the partnership in MTCC Africa, I'm the energy efficiency expert, and I was involved in the project Pilot 1, which was a pilot project on energy efficiency operations in ports. The project entailed undertaking a level 1 energy audit for the port of Douala, level 2 energy audits for the port of Mombasa, and also it included doing an analysis of all the audits that have been carried out at the port of Mombasa. The key objective of this project was to ensure energy efficient operations in various activities that the port is involved in, sustainable operations, and that energy consumption is reduced in all operational cases. The project has been quite instrumental, especially in capacity building for the staff of various organizations, not only in Kenya but also in the focal points countries, where we have been doing capacity building for the staff of other countries in terms of energy efficiency. Guided by the Green Port Policy and several studies that have been undertaken, including energy audits as stipulated by EPRA, the port has been undertaking various energy efficient projects to ensure that our operations are sustainable and energy efficient. Some of these projects include installation of 3 solar power plants, one with a capacity of 300 kilowatt peak, second one with a capacity of 450, and the third one with a capacity of 300 kilowatt peak, all of which have combined capacity of more than 1 megawatt in terms of solar power that is supplied to the grid and used in the new service area and the cruise terminal at the port. The other initiative that the port has undertaken is retrofitting all high-consuming lamps, especially the tower lights lamps, with the LED lamps, which are less consuming, to an extent of even less than 3 times the initial lamps which had been installed. The port has also been installing high-efficient air conditioning systems, where we are shifting away from the conventional air conditioning to high-efficient ones, including the VRFs and the inverter type air conditioners. The port has also been involved in purchasing of hybrid RTGs, which consume less diesel in terms of the prime power. The engines of the hybrid RTGs are also the highest in terms of energy saving, where Tier 3 in the European equivalent is used in the port. This ensures that there is a lot of saving in terms of emissions to the environment, and that the regenerated power is reused during hoisting in the operation of the RTGs. We also have all the tugboats which have been procured recently, having shore power facilities ready for connection to shore power once we have the facilities installed at the port berths. In addition, all the Abba mobile cranes are installed with the electric option, where once we have the shore point connections at the berths, then we shall shift away from the use of fossil fuels to the use of electricity supply to the cranes. And this will improve on efficiency in operation and less emissions to the environment. Being in the maritime field, my recommendation is that if all the ports in the East Coast sea line could implement shore power and have the facilities ready for connection, it will be more easy to sell the project to the shipping lines, to have them incorporate the gadgets for connection to the shore power, because in so doing they will be connecting to each and every port that they visit at the coastline. This will make the project viable in a business case, and it will be a plus in the African setting to show an example to the world on how to reduce on emissions along the sea.
My name is Joseph Kihunyu, Electrical Superintendent RTGs. We handle repair and maintenance of RTGs. That is an abbreviation for rubber tire gantry. As you can see, it runs on rubber tires. The RTG main purpose is to load and offload containers, either loaded or empty, from the truck to the yard or from the yard to the truck. In the process, the RTG has several components that is comprised. We have the structure, we have the engine, we have the electrical, electronic systems, and all these work together to form the RTG. The RTG runs on diesel. It has a diesel engine. It has an alternator or generator that generates power, that is electrical power, that is used on the equipment. It's a fully electric equipment. This RTG, as I've said, runs on diesel. If there is a way we can be able to utilize the equipment with a lesser amount of diesel, the better saving to the authority. So in order to implement this, we have two versions of the rubber tire gantries. One of the versions, that's an older version, does not utilize the hybrid system. This RTG that does not utilize the hybrid system consumes more as compared to the one that has a hybrid system. It also has a bigger engine that has a bigger capacity. That we're talking of a 15-liter diesel engine. But for the hybrid, we have a 9-liter diesel engine. And in terms of efficiency, these two equipment do the same job, the same size, the same height, the same capacity of containers. So in order to be able to appreciate the energy efficiency of the hybrid system, I would wish to explain briefly the older version, and then we can be able to compare with this other version. The older version of the rubber tire gantry, as I've said, has a bigger engine, and the bigger the engine, of course, it comes with its associated expenses in terms of it has a bigger capacity for oil. That means in one maintenance cycle, if you drain the oil and put, we are talking of almost 90 liters of oil. It also has bigger filters. These filters, the bigger they are, the more expensive they are. So there's an element cost in terms of maintenance. When you look at the generator, the also capacity is big. We are talking of 500 kVA generator being run by the engine in order to propel the equipment to do the same piece of work that is done with the hybrid. When you look at the hybrid, it has a smaller engine. The generator is also smaller, 268 kilowatts generator. But the work that it does is exactly the same as the work that is being done by the older version. So in order to implement the hybrid system, the original equipment manufacturer has installed a capacitor bank. This capacitor bank acts as a storage of power. We know when the equipment is running, it is during the lifting of loaded container that it draws much power. During the lowering of that load, because of gravity, the motor acts as a brake to prevent the load from free fall. In that scenario, the motor generates energy. This energy in the older version is dissipated into the resistor bank. But with this version, it is that extra energy that is used for charging the capacitor bank. So that in the next cycle of hoisting up, where a lot of energy is demanded, now the capacitor bank, together with the power from the generator, goes into the motor so that it's able to lift the loaded container.
My name is Engineer Douglas Mugalo. I'm a design engineer for Kenya Ports Authority, and I work at the Port Electrical Department. This plant was built through funding of Trademark East Africa in two phases. There was the first phase of 410 kilowatts undertaken by Masterpiece Electricals Limited, and the second phase of 350 kilowatts undertaken by Hypertech Electrical Services. The purpose of the plant is to power the new services area of the Ports Authority. The objectives have been met. I would recommend this system to other industries because of the savings we have experienced in our power bills. We have saved up to 30% of our power bills. Also, there's the advantage of the clean energy, green energy, which eliminates the carbon emissions, and we have the greenhouse effect.
My name is Wesley Rabongo. I'm the senior electrical engineer in charge of installation inside port. The light you can see here is one of our LED lights that we use on the monopoles. The monopoles are those big poles you saw when going around the port. We've got two different types in terms of the height. We have the monopole of 30 meters and another of 40 meters. And they are fitted with a different number of luminaires depending on the locality. What I mean by locality is that those that are close to operational areas, we give them high illumination. Those are just for the yard illumination, we give them less numbers of the luminaires. So we've got the highest carrying 12 luminaires up on the carriage, and we have the lowest carrying 7 of them. But they're all of LED, that's the light emitting diode lights. Initially we used to have the HPS, that is the high sodium pressure lights. But when we retrofitted, we replaced with the LED lights. And I believe LED has got so many advantages compared to the high pressure sodium lights. Like one, you can see they're very bright, and they consume very little power compared to the HPS. And they are also not that bulky, they're light in weight. And you also get maximum light spectrum from them. In terms of wattage, this one is a 640 watt LED light. And initially we used to have the HPS, the light itself was 1000 watts, and the choke was also 1000 watts. So they were drawing a total current of 10 amps. And as they age up, the longer they stay, they used to now even consume more current. But this one is a standard LED light of 640 watts, an efficiency of 0.95, and they consume a maximum of 3.05 amps. So you can see in terms of saving, we have really saved a lot by introducing these lights. And again, with the lifespan, they've got a very big lifespan. So even our maintenance has been reduced. The frequency of lowering the poles to bring them down to replace the bad lights is not that frequent. Actually, it's once in a while. But we still keep on doing the maintenance of the monopoles. We've got samples of the old HPS lights which are placed outside. They are so bulky. Like these I was able to carry all alone all the way up to here and install. But if you were to do for the HPS, we need to get the igniter choke and that bulk light.